All right, so we're going to go through a couple quick summary things, just hopefully as a refresher before your upcoming Unit 1 test. So first thing we're going to talk about is how we do our representations of intervals. So this is inequality notation, set notation, and interval notation. So if we're talking about a finite interval with a definite starting and stopping point, that's this top line here. So as an inequality, we'd say, let's say x is greater than or equal to a, which is less than or equal to b as an inequality. Then in the set notation, we put it inside the curly brackets with the x and the bar that represents such that. And then interval notation is where we do just the smallest value and the biggest value in either the parentheses or the square brackets. Parentheses if we are not including the value, square brackets if we are. We have infinite intervals. That means we're either going to be looking at really large numbers, such as x greater than a, or really small numbers, such as x less than or equal to a. And again, interval notation, if we're looking at those big numbers, x greater than a, that means our smallest value we hit is at a, and the largest value we go up to positive infinity. And if we're looking at those small numbers, x less than or equal to a, that means our smallest number we hit there is at negative infinity, and our largest number we hit is at a. We're going to go through skipping quite a bit of this since this is hopefully just a little refresher. But if we do want to look at these in our notations here, so just on the number line, if we look at our inequality, our smallest value we hit is at -3. It's a filled in circle, so we're including it. So we had to put x in between, and then the highest number we hit there is at 2. If we put it in set notation, we put our curly bracket, x such that, and then the exact same thing we had there in our inequality inside that curly bracket. In our interval, we take our smallest value we have, -3. We take our largest value, 2. We are including both of those endpoints, so we put the square brackets. Similarly over here, this time we're not including the -3, so we'll just be less than. We are still including that 2 as an interval, all x such that -3 is less than x, which is less than or equal to 2. And again, this time we're not including that -3, so we have to use the parentheses instead of the square bracket. So moving along, I think next comes up is end behavior. So just a recall, domain of a function is the set of input values x, all of the possible x values that exist on our function. And the range is a set of the output values f of x. Again, the range is the y values. It's all the outputs, any possible y value that you can have. Now, the end behavior describes what happens to the y values when the x values either increase without bound, either they get bigger, approaching positive infinity, or decrease without bound as they approach negative infinity. So if you look at the linear function here, we always write our symbolic form like this. This is how we write end behavior each time. You do need to know this notation. So we always look first as x approaches positive infinity. So as our graph moves to the right, what are happening to the y values? Well, in this case, they are going up into positive infinity. So as x goes to positive infinity, f of x, the y values are going up into positive infinity as well. Second thing we look as x approaches negative infinity. So as our x values move to the left, what are the y values doing? Well, this time they're going down, so they are approaching negative infinity. If we look at their example here, we've got a quadratic function, f of x equals to x squared. So when we look at the domain, what are all of the possible x values that exist in our function here? Now notice these arrows are going up and out. So they're going up into the left this direction. They're going up into the right this direction. Since we do have arrows, that means those lines are increasing. They're going on forever. So that means it's going to hit every x value. So our domain is all real numbers, negative infinity, positive infinity, whichever equation, or sorry, whichever way you'd like to write that. Now the range is the y values. So we always look from the bottom to the top. So as we check from the bottom to the top, the first y value we hit is right here at 0. And then as we continue going up, again, our arrows are going up. So that means our range, our possible y values, the smallest y value we have is at 0. We are including it. and it's going up then into positive infinity. So the end behavior, again, end behavior, we're looking as x goes to a positive infinity. So as we look to the right of the graph, what are the y values doing? Well, look, they're going up into positive infinity. And then we also look as x goes to negative infinity. So as we look to the left on our graph here, what are the y values doing? Well, they're still going up, so they are also going into positive infinity.